Hello, ladies. I'm sorry I couldn't be there today. I have a sick kiddo at home. I wanted to make this video so that we could go over simulations and how to do them, because simulations can get a little tricky, and I want to make sure that you have a solid example before going straight in. To give you a little recap from yesterday, we talked about the simulation process, and I kind of broke it down into 3 steps. So when you're simulating a chance event, the first thing you need to do is describe how to use a chance device to imitate one trial, aka we're going to call it like a repetition of the simulation. You're going to tell what you're going to record at the end of each trial. Number 2, you're going to perform many trials of the simulation. And then 3, you're going to use the results of the simulation to answer the question of interest. Now these sound a little bit vague, so I'm going to walk you through each of these steps with a specific example. And that example is the example we looked at yesterday. So the example we looked at yesterday we called airport security. And I'll go ahead and read it out loud. The Transportation Security Administration, TSA, is responsible for airport safety. On some flights, TSA officers randomly select passengers for an extra security check prior to boarding. One such flight had 76 passengers, 12 in first class and 64 in coach. Some passengers were surprised that none of the 10 passengers chosen for screening were seated in first class. We want to perform a simulation to estimate the probability that no first-class passengers would be chosen in a truly random selection. So basically, we're questioning the TSA, and we want to know what is the likelihood of getting 0 first class out of 10 passengers. So now the question is, how do I do this? Right, so let's go back to step 1. Step 1, I need to set up my random chance device. So I need to use the given proportions that were given to me to sort of set up my random chance device. For example, when we played the 1 in 6 game, we used a dice because we needed 1 to be the winner and 5's options to be the losers. So we decided that we would roll a die, 6 would be the winner, 1 through 5 would be the losers. That would represent the proportions given or likelihood probabilities of winning. Now, in this example with the TSA, we have first class passengers and we have coach passengers. There were 12 passengers that were first class and the rest of the 76 passengers were coach. So how could I do that? That's a lot of numbers. That's more than a dice. That's more than a coin flip. So a random digits table is going to be our best bet here. So the way I would set this one up is I would say 0, 1 to 12 are going to represent first class individuals, and 13 to 76 are going to represent individuals who are in coach. And then I'm going to ignore all other numbers. Okay, so step 1 is just set up my random chance device, right? And then the next step would really be to say how you are going to do this. And that involves number 2. So we're going to pick numbers from the table until you reach the number selected in the example, and this is considered one trial. So in the example that I just set forth, there were 10 people randomly selected from the TSA, and 0 of them were first class. So we had 10 people selected. So we want to take our random digits table and look, okay, I'm going to look for 10 numbers. When I find those 10 numbers, I'm going to see which of those numbers are going to represent first class. So this time there were 10 people selected at random, so I would pick 10 numbers looking at no repeats because once a person is selected, they can't be selected again from the TSA. Then I would repeat this with many trials. We did this with the 1 in 6 game. When we were using the 1 in 6 game, you had the likelihood that 3 people out of 7 could be winners. So you took a trial of 7 individuals and you saw how many times 3 or more of them won. That would be one trial. You then repeated that trial 4 more times for an addition of 5 repetitions. Hopefully that makes sense, the difference between a trial and a repetition. Okay. So now what we need to do is we need to use the results to draw a conclusion. So I would take, in the TSA example, I would take my 10 individuals, or the 10 numbers that I picked, and I would see how many times did I get 0. So total up the number of times that 0 first-class people were chosen, and then I would count that out of the number of trials that I did. So let's say in trial number 1, I picked 10 numbers. One of them was a first-class passenger. Then I do another trial. 2 of them were first-class passengers. Then I do a third. 0 were third-class passengers. Then I would say, well, 1 out of 3 of my trials had 0 first-class passengers. So then I could use those results to draw a conclusion. I know this is complicated, so I want to give you some time to actually practice it with this example. So I'm going to have you and the woman next to you perform one trial of the simulation using the random digits table that you see before you. So you're going to copy the digits onto your paper and mark directly on or above them so that someone can kind of follow what you did. All right, and then once you've done that, then you're going to basically say, okay, well, in 15 of the 100 trials of the simulation, none of the 10 passengers chosen was seated in first class. Does this provide convincing evidence the TSA officers did not carry out a truly random selection? Please explain your answer. So I'm going to give you a little time to do that, and I guess I'll just, I don't know, listen to some Kahoot Halloween music. Okay, if you still need some more time, which I think you might, go ahead and pause the video. Okay, so now that we're back, let's go over the answer to B. So for B, this is what I would have done. So looking at the numbers here, I have bolded the numbers that I would have chosen that are actually in our range. So 71, that's a coach passenger. Then I would look at 48, coach, 70, coach, 99, out of range, 84, out of range, 29, coach passenger, 07, ooh, first class, underlined. Just so we know this represents something different. 71 is a repetition, so I would ignore it. 48 is a repetition, so I would ignore it. Then we have 63, 61, 68, 34, all of which are coach passengers. Then we have a 70, which is out of range, and a 52, which is a coach passenger. And that brings us to our 10th and final number selected. So if I look at all of these bold numbers, only one of these bold numbers is a first class passenger. Okay, so let's go on to C. In 15 of the 100 trials of the simulation, none of the 10 passengers was seated in first class. Does this result provide convincing evidence that TSA did not carry out a truly random selection? Explain your answer. Well, 15 out of 100, this should be some nice math, is only 15%. But 15% is larger than 5. So I would say, do I have convincing evidence that TSA officers did not carry out a truly random selection? No, I don't have convincing evidence. 15% of the time you will get results of 0 first-class passengers being selected. So I have no reason to believe that they have not carried out a truly random selection. Okay, now this is number 12 from your homework that is due tomorrow. And I wanted to go ahead and put this up here so that I wanted to give you a chance to work on this with the woman next to you. So this is looking at Scrabble. So in the game of Scrabble, each player begins by randomly selecting 7 tiles from a bag containing 100. There are 42 vowels, 56 consonants, and 2 blank tiles in the bag. Kate chooses her 7 tiles and is surprised to discover that all of them are vowels. We want to perform a simulation to determine the probability that a player will randomly select 7 vowels. So I need you and your partner, again, you're writing this down, to describe how you would use a random digits table to carry out this simulation. Be sure that you are very specific about the random chance device that you're going to use and what would represent what in this random chance device. Then you're going to perform one of the trials, and then you're going to draw a conclusion. So work on this with the woman next to you. When you are done, then you can go ahead and start working on your bias project. If you have any questions, you can email me.